All right. So things. Let's start with this problem. Okay. So last example of regression lines. Okay. So we have already done three types of examples of regression lines. Okay. That types can be appear in your exam. Okay, I will share this PPT with you today. Okay. After lectures. Okay. Also, I will share the assignments of this assignment unit number 2, and after that I will let you know when you have to submit your unit number 1 assignment and unit number 2 assignments. Okay, I'll give you time, no problem, but don't have much time. Okay, so you have to prepare accordingly. So let's proceed for this example. The number of bacterial cells y per unit volume, okay, in a culture at different hours. Hours is given by x and y is going to be the number of bacterial cells per unit volume. Okay, is given below. First, they ask you to fit the regression of y on x and x on y. So this is given data set is given to you. Now, how many numbers of data sets is there? So n equals to, you can easily find out. So you can find total number of data sets and 9, I think, or 10. Okay. 0 to 9 means is 10. Okay. So you have to find the regression line of y on x and x on y, both. So at last you have to estimate the number of bacterial cells after 15 hours. What would be the answer? Let's go for it. So first thing is n equals to 10. You can easily identify n equals to 10. And according to that, you have to construct the table. Table means x values, y values, x square, x, y, and y square. So you know how to calculate each and every stuff, right? Like x square means you have to do the square of each and every terms. 0 square, 1 square, 2 square, 3 square, like that. Xy means you have to multiply x and y, and you will get over here these terms. Okay, just multiply each and every x and y terms, you'll get it. At last, y square. You have to take the square of each and every square term square of y. Once you're done, you will just go for the sum of x, sum of y, sum of x square, sum of xy, sum of y square. Now you have to calculate the formula. Okay, go for the formula. Formula will tell us bxy and byx. We have to calculate, right? What is byx? Byx is covariance of xy by sigma x, right? Covariance of xy by sigma x. Not sigma x actually, sigma x squared actually. Means summation xy minus summation x summation y. Summation xy. Go for the table. Check the table. Summation xy means this one. Okay, you have the reference, like this table is with you. Okay, you have already calculated. Now just you have to put those values into the formula. Okay, if you put the values into the formula, we'll get the results. So what is byx? Byx summation xy minus summation x summation y by n. Each and everything we have calculated. Summation x equals to 48, summation y equals to 1488, summation xy equals to 8924, n equals to 10. Put over here n equals to 10, and similarly the below. Okay, thumbs. After calculating, I'll get this result. So byx equals to this. Now bxy equals to, similarly we'll get this form using the formula. Once we have calculated byx and bxy, next we have to calculate r. Okay, okay, you can go for x bar or x bar and y bar, both is possible. X bar means summation x by n, y bar means summation y by n. Okay, means arithmetic mean of x, arithmetic mean of y. Next thing is that the equation of the regression line equals to y minus y bar equals to byx times x minus x bar. Y minus y bar equals to byx, because y on x, I'm calculating the regression equation of y on x. That's why byx, we are using byx. Okay, y minus y bar equals to byx times x minus x bar. plug in, just plug in the values. Y minus y bar equals to 148 by 8.8. Put it. And byx we have calculated 27.0061. Put it. X minus 4.5. 4.5 is this x bar. Put it. After calculation, I will get this result. So this is going to be equation of y on x. Regression equation of y on x. Similarly, we can calculate regression equation of x on y. It's also possible. X on y means x minus x bar equals to bxy times y minus y bar. Put it. If I put the formula, we'll get these things. So it simplifying, we'll get x equals to 0.033x. Okay, 0.366y minus 0.9461. Just multiplying and calculating, simplifying these things. Once I get it, I've done this first questions has been solved. Fit the lines of regression y on x and x on y. We have done it. Okay. Next thing is that also estimate the number of bacterial cells after 15 hours. Number of bacterial cells after 15 hours. So what is given to you? These questions are important. What is given to you? 15 hours is given to you. Now 15 hours is x or y. If you observe, this x is going to be your denoting the hours, number of hours. So x is given to you. So what you have to find? Y. X is given to you. X is 15 hours. So what you have to estimate? You have to estimate y. That means which equations will help you? Y on x or x on y? Which equation will help you? Y on x or x on y? Y on x will help you, right? Y on x will help you because we have to estimate y, and what is given? X given, right? So we will use this equation now. We'll use this equation to estimate that. Now x equals to 15. So x equals to 15 we'll put over here. We'll get the results. So after 15 hours, y equals to this. So that is how we can calculate this kind of problems, can solve this type of problems. Please let me know. This was the last problem of this unit. Okay, after that I will move on to the next unit. If you have any problem, any query, please ask me. I will revise, no problem. Then write down C on chat box. Quick. Not getting any responses. Write down C on chat box if it is clear to you. All of you write down C on chat box if it is clear to you, this problem. Okay, good. Okay, please also note down. Once you're done, please let me know. After that, I will move for the next unit. This unit has been over. All right. So this is all about the unit number 2. Okay. So we have completed unit number 2. Now the next task is to move on to the unit number 3. Now I will share with you this whole PPT of unit 2, as well as I will share with you the assignments. Okay, and I will give you the deadline of assignments. Yes, Vivek, I will do it on the next lab hours. Okay, in the next lab hours, please remind me. Okay. So unit 3, let's start unit number 3, random variables and probability distribution. last unit of statistics. After that, one more unit is there, and that will be the total last unit, that is error and approximation. It's very short unit. Okay, so this is the last main major unit will be there. Okay, this is unit number 3. After that, unit 4 is there, but this is I think it will take maximum two lectures to complete. So let's proceed. Unit number 3, random variable and probability distribution. So first of all, what is random variable? A random variable x is a real valued function. Okay, real valued means it can take any real number from minus infinity to plus infinity of an element, okay, of a sample space of random experiment. Like an example, when a correct coin tossed or fair coin tossed. So fair coin tossed means the sample space. Okay, so sample space of it after tossing the coin will have the two possibilities. Either it is head or tail. So the sample space is head and tail, H and T within curly bracket. So total possibilities are 2. That means the sample space is equals to H and T. If X is a random variable denoting the number of heads. Now I will let you know about the random variable. So random variable is a number. It's a random number. Okay, denoting the number of heads. Okay. Denoting the number of heads after tossed. Okay, it can be 4, it can be 5, it can be 10. Okay, so random number, right? Just a minute. All right. So as I told you, X is a random variable denoting the number of heads after toss. Okay. So it is just person to person varied, right? I mean, if I ask you person X to tell what is the random variable, he can say random number is 10. Someone can tell random number is 12. Yes, X is just a random variable. Okay. So now X of H equals to 1 and X of T equals to 0. Okay. Means what? Means like any random number we can allocate 1 and 0. If it is like tossed like head, then we can say that the number of random number is 1, and tossed like t, t means tail means fail, right? Because already we have this denoted like x is a x is a random variable denoting the number of heads. So when it head will appear, that means it is like success. Head appears means success. Success means x of h. You can say x of h, or you can say sometimes p of x h. That is also probability of h. Okay, not exactly x of h, p of h. It's better to say. P of h is 1 and p of t is 0. Here the random variable x can take two values, either 0 or 1. Either success or failure. There is no in between. Either 0, 0 means failure, failure means tail appears, and 1 means success, success means head appears. This is what the scenario is. Okay. Now, when a fair die is tossed, second case is when fair dice is tossed. Dice means it is having total 6 face, right? 1, 2, 3, 4, 6, 5, 6. So this is a sample space. X is a random variable denoting the square of the number. Okay, so X is a random variable which is denoting the square of the numbers obtained by obtained. Okay, like x of 1 equals to 1, x of 2 equals to 4, because I told you that so this is a random variable which is actually the square of the number. So each and every number, to 6 numbers is there. So 1 square is 1, 2 square is 4, 3 square is 9, 6 square is 36, like that. So these are the random variables: 1, 4, 3, 6, 3, 1, 4, and then 9, 16, then 25 and 36. These are the random variables. In this case, we are denoting x is a random variables. So random variables contains these values. Okay. 1, 4, 9, 16, and 25 and 36. These are the random variables. Now, there are types of random variables as there. Two types of main random variables. One is discrete random variables, another one is continuous random variable. Discrete means we can count separately. Okay, discrete means we can count separately 1, 2, 3. Okay, we can discretize them 1, 2, 3, 4, 5. Continuous means there is an interval. Okay, in the interval, lots of values are there. Okay, lots of continuous flow is there, which cannot be discretized. Okay, discrete means we can easily count whenever we can count separately, that is discrete. We cannot count in the interval, then it's continuous. So discrete random variable is a variable which can only take countable number of distinct values, and discrete random variables are usually counts. Okay, we can count, not necessarily, but generally we can count, like dead or alive, number of die, number on a die. Okay, number on a die, children in a family, number of defective items in a box. These are the count. We can easily say that how many persons are dead or alive. Okay, so number of numbers showing in the die, 1, 2, or 3, whatever. Children in a family. Okay, in the family, how many children are there? This count is possible. Okay, that's why it's a discrete random variable. Continuous random variable which can take infinite number over possible values in a given interval. Continuous random variables are usually measurement in an interval, like height in an interval. We can say, sometimes we can say so specifically, but many times we can say this is height is from, let's say, 5 centimeter to 9 centimeter. Weight, okay, in between this 12 kg to 20 kgs. Blood pressure, okay, real numbers between 1 to 5. I mean, whenever we are talking about unsure values, and I'm not sure about the values, okay, that measurement, we are not sure about the measurement. That measurement is known as a continuous random variable. I'm not sure, right? Not sure means I will predict some intervals, right? I'm not sure means what? I will predict some intervals, like 0 to 5. Okay, so what is your age? If someone asks you what is your age of your parents, okay, you don't know. Okay, it might be 62 to 70, 67, 62 to 67 in this interval. So that is a continuous random variable, not exact random variable, not a discrete random variable. Okay. Now, next thing is the probability distribution. Probability distribution, a graph, table or formula that specifies all possible values that a discrete random variable can take along with associated probabilities. Then it is called a probability distribution. Likewise, This is an example of tossing a fair coin 3 times. If I toss a fair coin 3 times and x is a random variable, we can denote the random variable as the number of heads obtained. We are tossing the coin 3 times and x is a number of head obtained. So what are the possibilities of random variables? The values of x. The values of x can be 0, no head occurs, no head occurs. Okay. Because we are tossing total 3 times. How many times? 3 times. First time toss, tail. Second time tossed, tail. Third time tossed, tail. So what is the value of random variable? 0. Next possible value of random variable 1. 1 means only one time head occurs. And only one time head occurs means how many way it is possible. It can occur in the first attempt. It can occur in the second attempt. It can occur in the third attempt or third tossed. Okay. X can be 2 also, that is 2 head. 2 head also possible, like this three possibilities: HHT, HTH, and THH. Okay. And the last one is 3 heads. 3 heads means all 3 heads is a very rare condition. It will occur like in only one possibility, that is HHH. Okay. So whenever we toss a coin, fair coin, okay, 3 times, the number of heads occur is called the random variables. The number 0, 1, 2, 3, these are the random variables. Why it's a variable? So it is varying. The x is varying. It can be 0, 1, 2. Now you can ask me, it is discrete or continuous? It is discrete, because 0, 1, 2, 3, you can count how many numbers of it. 1 numbers, 2 numbers, 0. We can count. That's why it is a discrete random variable. Okay. And these are the sample space. These are the sample space. TTT, this thing, this thing, this thing. Whenever x equals to 1, what is the sample space? Whenever x equals to 2, what is the sample space? Like this. Okay. We can easily tell you like that. Now we can go for the probability. How to decide the probability? What is the probability? Now, total count of the sample space. If I tell you the total count of the sample space, how many possible way we can handle the situation? One is all T, one is HTT, THH, THT, TTH, HTHT, HTH, THH, and HHH. So how many total? Total is 8. Total possibility, total number of possibilities, okay, of the sample space. Total number of possibilities of the sample space will be 8. So always this 8 will be in the denominator. Always this 8 will be in the denominator. What are the total possibilities? What are the total possible cases in 3 tossed? Okay, if it was 4 tossed, suppose if I toss like 4 times, so it will be total 16 possible cases. That's the formula. Formula is there. Like 3 times toss means there are 2 possibilities. Okay, only head or tail. That means 2 outcomes is there. So 2 power 3, because we are tossing 3 times. So 2 power 3 means 8. So total possible outcomes is 8. And samples possible outcomes is whenever x equals to 0. Whenever x equals to 0, we have only one scenario. That means 1 by 8. So probability becomes 1 by 8. Now you can, if I ask you, what is the probability that there will be no head occurs in this scenario? In this scenario, what is the probability that there will be no head occur? That probability of x1, you can say x1 is equals to 1 by 8. What is x1? X1 means no head occur. Or you may say probability of x equals to 0. You can say vital probability of x equals to 0 equals to 1 by 8. Probability of x equals to 0 equals to 1 by 8, because x equals to 0 means x. What is the meaning of x? X is the number of head obtains. X is number of head obtains. So probability of x equals to 0, that means number of head obtains is 0. Is what is the probability? Probability is 1. 1 means only one sample is there, that is TTT, out of how many? Out of 8. 1 out of 8. Similarly, if I ask you probability of x equals to 1, that means only one head occur. Only one head occur. What is the probability in this scenario? This x equals to 1, look at this. Now it is a sample space. For x equals to 1, 1, 2, 3. So it is 3 out of 8. 3 by 8. Similarly, probability of 3 heads occur. Again, 1 by 8. Probability of 2 heads occur, 3 by 8. If I add all them, if I add all of them, interestingly, we'll get 1. 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. Interestingly, we'll get 1 only. And remember, the probability value of any function, any variables, random variables, always maximum it is 1, minimum it is 0. Maximum it is 1, minimum it is 0. Not greater than 1, not neither less than 0. Okay, is that clear? This is on probability distribution. Any doubts, please ask me or write down C on chat box if it is clear to you. All right. Okay, good. So next thing is that, yes, as I told you, these are the probability distribution. And in this graph, you can easily identify what is the probability of each and every random variables when x equals to 0, when x equals to 1, 2, and 3. It's given in the bar diagram. Now, probability function. So x is a random variable, then probability function p of x maps the possible values of x against the respective probabilities of occurrence. P of x, okay. P of x, x is any random variable, so P of x is going to be the function, probability function. So if P of x the probability function, then as I told you, the value of probabilities always lies between 0 to 1. Okay, maximum value is 1, minimum value is 0. We cannot find any probability which is greater than 1 or less than 0. It's not possible. Then it's going to be a wrong calculations. If I add the sum of all distributed probabilities, if I add them in the last example, if we added all the distributions, all the probability distribution, we get 1 only. Okay, in the discrete case, if I add them, I will get only 1. Probability function is called the probability mass function. This probability is called probability mass function. This mass stands for discrete. This mass stands for discrete. Another one is called probability density function. Density stands for continuous. Okay, so probability mass function in case of discrete probability, or probability density function. This density function is known as for continuous random variable. So for discrete random variable, we'll have probability mass function PMF. For PDF, for continuous random variable, we'll have PDF or probability density function. Let's go for it. Let's consider some example of tossing a fair coin 3 times like the last one. X is the number of head obtains. Similar case, x equals to 0, x equals to 1, 2, 3. Okay, these are the examples. Now, the value of all values of probabilities you can easily find must be less than equals to 1 and greater than equals to 0 for every x. Okay, you can easily identify. And summation of x, p of x, summation of p of x means if I add all these things, I will get 1 only. 1 by 8, 1 by 3 by 8, I will get 1 only if I add them. Okay, so p of x is called probability function. It's called probability mass function. These are known as probability mass function, PMF. What is the PMF? This structure, this specific table is known as PMF. This specific table is known as PMF, probability mass function. Let's go for another example. A fair die tossed once. If a random variable is getting an even number, okay, find the probability distribution of x. We have a fair die. Fair die means it is how many outcomes may be possible? It's 6 outcomes. 1, 2, 3, 4, 5, 6. Okay. But we have a random variables getting an even number. Even number means out of 6, how many even numbers is there? 2, 4, and 6. 3 even numbers. Now we have to find the probability distribution of x. Now first sample space. Okay, total possibilities. Total possibilities is 1, 2, 3, 4, 5, 6. Okay, these are the sample space because we have a fair die. So in fair die, what are the possible outcomes? Total possible outcomes is 1, 2, 3, 4, 5, 6. Now what does this x stands for? X stands for random variable getting an even number. So hence x can be either 0 or 1. Okay, means what? Means x equals to 0 means whenever I'm failed. Failed means whenever I'm getting the outcomes like 1, 2, 1, 3, 5. Whenever I'm getting the outcomes like 1, 3, 5, then what is the probability? Probability is 3 by 6. Total possibilities are 6. Total possibilities are 6. And I'm getting 1, 3, or 5. 1, 3, or 5 means not a even number. It's an odd number. So x equals to 0. X equals to 0 stands for fail. Fail means odd numbers. Fail means odd numbers, right? Because we want random variable getting an even number. That is our success. Getting an even number is a success. So x equals to 0 means what? X equals to 0 means probability of 1, 3, 5. Getting 1, 3, 5. 1, 3, 5 means what are the sample count? Total sample count is 3. 1, 2, 3. So this is a 3 out of how many? Out of 6. So 3 by 6 means 1 by 2. So probability of x equals to 0 means probability of 1, 3, 5 getting outcomes as 1, 3, 5 is 1 by 2. Similarly, probability of x equals to 1. Probability of x equals to 1 means it is success. 1 means success, right? Success means getting even number. Through 2, 4, 6. Sorry, not 2, 3, 6. It's 2, 4, 6. Again, it is how many numbers are there? 2, 4, 6. That is total 3. So outcome is 3 by 6. Again, it is 1 by 2. So 1 by 2 and 1 by 2 is going to be your right. So these are going to be your PMF. This is your PMF, probability mass function. Even you can calculate some the value of probability of x always lies between 0 and 1. If you calculate the probability is 1 by 2, 1 by 2. Both are belongs to 0 and 1. If I add them, I will get 1. 1 by 2 plus 1 by 2 equals to 1. Okay. Just tell me if it is clear to you, or else ask me your doubts. Write down C on chat box if it is clear to you. All right. All right. Let's go for the next example. Check whether P of x equals to x by 6 and the value of x equals to 0, 1, 2, 3. It's probability mass function or not. Okay. So what to do? So function is given here, f of x or P of x equals to x by 6. The value of x is 0, 1, 2, 3. Just plugging in. Just plugging in the value of x when x equals to 0. When x equals to 0, P of x or f of x or P of x equals to x is going to be 0 by 6. 0 by 6 means 0. So when x equals to 1, how many outcomes is there? 0, 1, 2, 3, right? So we will put 1 by 1. X equals to 0, x equals to 1 means 1 by 6. 2 means 2 by 6. 3 means 3 by 6. Now we will add them. If I add them, and we will get the result like 1. First thing is that all the values are less than 1 and greater than 0. All the values are less than 1 and greater than 0. 1 by 0, 1 by 6, 2 by 6, and 3 by 6. But now next thing is that we have to check their addition, summation. If I add them, we must need to get 1. Otherwise, it is not a PMF, probability mass function. If I add them, we'll get 1 by 6, 2 by 6 plus 3 by 6 equals to 1. 1 is correct. That means it is a PMF. It is correct. P probability mass function. The probability mass function. Suppose if the addition is not equals to 1, either it is greater than 1 or less than 1, we'll stop there. We would say that Px is not a probability mass function. Okay. To have a mass function, to have a PMF, what we need to do? Need to take the sum of each and every probabilities, and the sum of the all probability is going to be 1 only. Okay. Let's go for the next problem. Find the probability distribution of a number of heads when 3 coins are tossed. Find the probability distribution of a number of heads when 3 coins are tossed. 3 coins tossed means total sample. All possible outcomes is 8. You can see is this one. X is the random variable getting heads, tossing 3 times. So X can take 3 values. As I already told you, this type of problems already solved earlier. No head means 1 by 8 probability. 1 head means 3 by 8. 2 head means 3 by 8, and 3 head means 1 by 8. So this is a probability mass function, and this is happening. We add them. So this is going to be probability mass function. Okay. We have already done this, so don't waste time over this question. We have already done this question earlier. Next question is check whether the function is below is a probability mass function or not. This is your task now. Giving you some times. Check it whether it's a probability mass function or not, and let me know. Quick. Write down your answer with justification. If it is a mass function, why? If it is not a mass function, why not? Write down on chat box. Very good. So I got responses from Pratik and Kusant. Yes, it's a PMF. First of all the values of the probabilities is less than 1 and greater than 0. If you observe less than equals to 1 and greater than equals to 0, you can observe 1.1, 0.4, 0.2, and zero point 0.3. Each and everything's are there. And if I add them, 0.1 plus 0.4 plus 0.2 and plus 0.3, you will get 1. So that's why it's a probability mass function. Okay. So very simple to check. Similarly, check the next one. It's also easy to check. 1 by 2, 1 by 3, 1 by 6, and 1 by 4. Please check it and tell me if it is a probability mass function or not. Please tell me whether this is a PMF or not.
No, sir.
Okay, Manoj, yes, it's not a PMF because
Yeah,
value
because
of
it's
all probabilities is less than equals to 1 and greater than equals to 0. That's true. But if I add them, I'll get 5 by 4. 5 by 4 is greater than 1. So it's not a PMF, right? Good. Similarly, this one again, here the problem is that probability of x equals to 0 is minus 1 by 2, which is not possible. Probability cannot be negative. Okay, so first condition is failed. That's why it's not a probability mass function. Okay, but if I add them, I will get the result addition equals to 1. Okay, if I add them, addition equals to 1, but this is not possible. Probability cannot be negative, right, of any values. Okay, that is not possible. That's why it's not a PMF. Okay, now check whether the function, okay, is a probability mass function or not. All of you check it and let me know. X value of x is equals to 0, 1, 2. Total 5 values are there. 0, 1, 2, 3, 4. Okay, check it and let me know quick. All of you check it and also write down your answer with justification. If it is a PMF, why? If it is not a PMF, why? So anyone completed? So in this case, first of all, you have to construct this table. Okay. So this table is that when x equals to 0, what is the probability value of that random variable? Okay. So first value is 0 by 0 square by 30. 0 square by 30 is 0 by 30 is 0, right? Second one is 1 square by 30 and 2 square by 30, that is 4 by 30, 9 by 30, 16 by 30, 1 by 30, okay? Like that. If I add them, I'll get 1. And all the values of the probability is going to be between 0 and 1. So it's a probability mass function. Like that you have to check in exam. Okay. All right. Next question is this one for you. Please check whether it is a probability mass function or not, and let me know on chat box with justification. Okay, all of you, quick check it and tell me with justification whether it's a probability mass function or not. Yes, Kusant, you're right. If you observe the first value is minus 1 by 5, which is less than 0, which is not possible. So it's not a probability mass function. We don't need to check the other values as well. Okay. So it's a correct. So just plug in x equals to 1. We'll get probability of 1 equals to minus 1 by 5, which is not possible. Probability value cannot be negative, right? That's why. Good. Next one is this. A random variable x has a probability mass function given by this. Okay, this mass function is given. Now find the probability between the probability of the values of x whenever it's lying between 2 to 4, and 2 is less than equals to and 4 is not less than, only less than. So how to calculate this type of things? First, probability of 2 less than equals to x less than 4. That means what? It is attaining the value 2. It is attaining the value 2 means we'll take probability of 2. Probability of x equals to 2 means 0.2. Okay. Next value is 2 to 4, but it's not attaining the value of 4 because it's strictly less than. So next value we have to take, that is 3. So probability of x equals to 3 means 0.5. So we'll add 0.2 plus 0.5. Finally, it will be 0.7. Okay. So why we did not add probability of x equals to 4? Because it is strictly less than. Okay. It is strictly less than 4. That means we don't need to add it. If it was less than equals to 4, then we could add probability of x equals to 4. And finally answer that like that. Now, whenever probability is x greater than 2 means not greater than equals to 2. Greater than 2 means there are two possibilities. One is 3 and 4. Greater than 2. One is 3, another one is 4. So probability of 3, probability of 4, we'll put it, we'll get it. X equals to odd. X equals to odd means which one is the odd number? Which one is the odd number? 1 and 3. So probability of x equals to 1 and probability x equals to 3. Just add them. 0.1 plus 0.5. We'll get 0.6. X equals to even. Probability of x equals to 2 and x equals to 4. Add them. 0.4. If it's clear, please write on C on chat box. Otherwise, ask your doubts. All right. So the next question is for you. Okay, random variable x takes the values, okay, from 1, 2, and 3 and 4, such that this condition is satisfying. Now your task to find the probability distribution. Think about it and complete this task and write down the answer. All right. So what we have to do here? So we will assume this equals to k. Whatever the equation is given to you, you have to assume this equals to k. Now, if I assume this equals to k automatically from this equation, quoting this with k, I will get probability of x equals to 1 equals to k by 2. Similarly, x equals to 2 is k by 3, x equals to 3 is k, and x equals to 4 is k by 5. Okay. So once I get this all values, so we know that the summation of, because this is a probability density must function, right? So the summation of all this probability of x equals to 1, right? This is by default true. So if I add all this like k by 2 plus k by 3, k by 2 plus k by 3 plus k by 5, I will get equals to 1, right? So if I add them, I'll get equals to 1, and finally we'll get the value of k equals to 30 by 61. Finally, we'll get k equals to 30 by 61 from here, right? 30 by 61, just plugging it, because we have to construct this form, right? Probability distribution. So this distribution will give like x equals to 1 means probability of x equals to 1 equals to k by 2. K equals to 30 by 61. So k by 2 equals to 15 by 61. Now k equals to x equals to 2. So x equals to 2 means probability is k by 3. So k equals to 30 by 61. So k by 3 equals to 10 by 61. Like that, plugging it, you will get the answer. This is your distribution. All right. Okay. So we are ending up to this problem. In next problem, we will go for the next session. So please write down your roll number and class on chat box, and you can leave now. Have a nice day.